Hi, welcome back to Mrs. O'Graham's Maths. We are doing the D&D worked solutions for the integration paper practice assessment number 2. Thank you again to D&D Resources for allowing me to use their materials and create these videos for you. All credit for the questions here goes to them. This is absolutely their work. I'm just making the worked solutions for you. Okay, so let's start with question 1. And we are integrating pi plus e to the pi x. Well, pi is just a constant, so that becomes pi x. And e to the x, if we integrate e, it just stays as e to the x. But because we have something inside of the function just here, then we need to divide by the derivative of that. So we would have 1 over pi plus c. This one we are told what the integral is equal to with limits to sub in. So let's do the integration first. Raise the power by 1, divide by the new power. K over x cubed, or rather minus k over x cubed, is equal to minus k x to the minus 3. So if we raise the power by 1, we've got x to the minus 2. We divide by the new power, we're dividing by negative 2. So that negative on the bottom cancels with the negative on the top to make a positive. And we're subbing in the values of 2 and 1. So if we put 2 in, well, 2 to the power of 4 is 16. We have k times x to the minus 2. I'm just going to rewrite this bit. So x to the minus 2 puts an x squared on the bottom here, just so that's a little easier to deal with the substitutions. So this will be k over x squared is 4, so then times it by 2, we have 8. Okay, putting in a 1, 1 to the 4 is 1, and k over 2 times 1, so just k over 2. And we're told that that equals 0. Okay, so if I do 16 over 4, that's 4. And let's just go over here. We'll have 4 minus a quarter gives us 15 over 4. We have 1/8 of k minus a half of k, which is minus 3/8 of k, and that's equal to 0. So then 3k over 8 is 15 over 4. So let's take 15 over 4, we'll times it by 8, divide it by 3, so k is equal to 10. See, we have a separating variables question, so we need to bring all the y's to one side and the x's to the other. So we take y over 1y dy is equal to 1 over x plus 1 dx, just by taking the dx to the right and the square root of y to the left. And we will integrate both sides. I'm going to rewrite 1 over the square root of y as y to the minus a half, because powers are much easier to deal with. So now we have, if we raise that power of y by 1, we'll have a half. We divide by the new power. Dividing by a half gives us 2. If we integrate 1 over a function of x, it's the natural log of x, and we will times by the derivative of the inside, except this time the derivative of the inside is just 1, so it doesn't change anything. Now we have some information here that can help us to work out the c. So when y is 9, x is 0, so we'll substitute those in. We have 2 times y to the half, well that's the square root of y, so that's 3. Natural log of 0 plus 1 plus c. Now if you check on your calculator, natural log of 1 is 0, so c is equal to 6. Now if we put that back into our formula, so 2 times the square root of y is equal to the natural log of x plus 1 plus 6. So when x is 11, we have 2 root y equals log of 11 plus 1 plus 6. Okay, so then log of 12 plus 6, divide it by 2, and then square it will give us y. And that rounds to 18. Part D, we need to integrate between two limits to find the area under the curve. We have our curve is cos x plus sine x squared. But as that is, we can't actually integrate that function like that. We don't have the skills at this level, so we need to use some trig identities to work this out. Let's first start by working out what that bracket squared is. So we would have cos squared x plus 2 sine x cos x plus sine squared x. Now that's just by expanding this bracket here. I haven't done any fancy work with trig identities just yet. We've just taken this as a double bracket and multiplied it out. Okay, so now we can look and see cos squared plus sine squared, that makes 1. So let's just pop that in. And 2 cos of 2 times sine x cos x, that one is on your formula sheet. If you take a look just here, we have 2 sine a cos a is equal to sine of 2a. So we can use that over here. So that becomes, well, hang on, I'm just going to write that down again. So it was 2 sine of 2a equals 2 sine a cos a. So just to show you what I'm doing, sine 2a equals 2 sine a cos a. So this bit here matches to what we have there. So we would have sine of 2x in this bit here. Okay, those two things we can now integrate. So 1 becomes x. Sine integrates to negative cos. And we will divide by the derivative inside because we're doing reverse chain rule. Then we will substitute in our limits, like so. Okay, now let's put those in. We've got 3 pi by 4 minus half cos of 2 times 3 pi by 4, so that's 6 pi by 4, minus pi by 4 take away a half of cos of 2 times pi by 4, so 2 pi by 4. Okay, over to the calculator. I just want to double check I've got all the brackets in the right place, because sometimes fractions go a bit weird on the calculator. Oh, here we go. Okay, so we've got that one, and then take away, actually let's do another bracket just in case. So pi divided by 4 minus half cos of 2 pi divided by 4 that equals 1.57, which I'm just going to go back and check. Yes, the question says we have to show the exact value. So 1.57 is not going to be accepted as an answer. We need to represent that in terms of pi. Okay, so let's do this the slightly longer way around. We can't just plug it into the calculator unless you have your calculator updated, in which case it would have given you an answer in terms of pi. My one on my computer is not the most recent one, so we have to go through the long way. Some of them do work out nicely, so you can see 6 pi by 4 cancels to 3 pi by 2, and cos of 3 pi by 2 is 0, so that one does help us. So that'll be a 0 just there. We're going to take away pi by 4 minus, okay, let's check out cos of pi by 2. So cos pi divided by 2, I'm going to need a bracket there. Ooh, there we go. Just there. That one is also a 0. So we're just left with 3/4 of pi minus 1/4 of pi. Well, 3/4 minus 1/4 is half. So it's pi by 2. Okay, let's do this. This looks like an application of differential equations, and it's population growth. So we're told that the birth rate is proportional to the number of fish present, and we have some information about that it's 2% of the number of fish present, but also fish are taken from the lake at a rate of 150 per day. So the rate at which our fish population is changing is going to be equal to 0.02, so 2% of the number of fish that we have, and we take away 150 from that each day. So T is measured in days, so the rate at which the fish are being taken from the lake is 150 per day. So the population itself is increasing by 2%, and then we take off 150 every single day. Okay, now we're going to do some separating variables to bring the n over to one side, the t to the other. If you have memorized how this goes, you can skip straight to what the equation turns out to be, but I will show you the steps as we go along. So the n part of this we bring to the left-hand side. And we have to always be doing divides and multiplies things, not adding and subtracting. So I can't separate off the 150 from it. And we bring the dt up to the right hand side with just a 1 left behind, because this function on the right here would have been multiplied by. Imagine it's in a bracket times by 1, and we've taken it over to divide on the left hand side. Now we will integrate both sides. Now if I integrate 1 over a function, I get natural log of that function. But we also need to divide it through by the coefficient of n there, because it's a reverse chain rule. If I integrate 1, I get just t, and then plus c. Now 1 divided by 0.02 is 50, so I can put that just there. My next line will be 0.02n minus 150 will be equal to 1/50th t plus c. I don't need to bother writing that the c is also divided by 50, because at this point we haven't worked out what c is. It's a constant, it's a placeholder, so it can just hold all of the numbers we need it to in there until we work it out. So then the next thing will be to raise to base e, so that we can get rid of the natural log on the left. So this will be e to the, I'm going to write that as a decimal again now, just to make it easier in the powers. All of that gets raised to be a power of e. Now e to the 0.02t plus c is the same as doing times e to the c, just by using powers. or laws of powers if you like, e to the c itself is just another type of constant, because e raised to the power of some unknown constant is still going to be an unknown constant, so we can make this easier on ourselves by calling it just one constant. So if we're timesing by a, it's the same as if I'd brought that a in front like this, and that's a little easier to do our calculations with. So then n will be a e to the 0.2t plus 150 divided by 0.02, which is the same as timesing by 50. So if I was to divide by 0.02, 1 divided by 0.02 we've just seen is 50, so it's the same as if I times that by 50. Okay, now let's get some information from the question so we can work out A. The information that's helpful to us is this 10,000, that's what we started with. So when t is 0, n equals 10,000. So 50 ae to the 0.2 times 0 plus 150 is equal to 10,000. So 10,000 divided by 50 minus 150. E to the 0 over here is just going to be 1. So I now have that A is equal to 50. So we've got all the pieces we need. Our last thing is to work out the time taken for the population to get to 15,000. Okay, so we want 15,000 as our population. We have A is 50, e to the 0.2, t is the thing that we're working out, the t value. Okay, so let's do 15,000 divided by 50. Or you could also put this into equation solver as well if you don't want to work through the steps. We're going to take off 150, divide by 50. What we've got so far is that e to the 0.2t is equal to 3. So if I take natural log of 3 and divide it by 0.02, I get 54.9 days. Okay, on to question 2. Okay, sectan is on your formula sheet. If we go and take a look at that now, where's that table gone? Here we go. So sectan is just here. Sectan integrates to sec. So this becomes sec of 2x. The 2 inside means that we need to divide by it because we're doing reverse chain rule. So 4 divided by 2 is 2. Okay, we're going to need our calculator for the trapezium rule. Again, look that up on your formula sheet. I'm just going to pause and write down the pieces of that. So there's that formula. We have half of h. H is the gap between these numbers here. So that's a gap of 10. So half of h is 5. Then we take the first y value, just here, plus the last y value, plus 2 times all of the other ones. Okay, then put all of that into your calculator, which I'm not going to go through doing that whilst recording, but that comes to 772.5, and we're measuring in minutes. Part C, we want the shaded area, so integrate between 1 and 4, or 9x over x squared plus 1. Now when you've got a fraction to integrate, your first check should be is the power of the top one less than the power of the bottom one, which it is, which means that the top is some form of the derivative of the bottom. If we differentiate the bottom, we get 2x. So to make that 2x into a 9, we would need to times it by 4.5. Or if you like, it's 9 over 2. So this, when we do have the top being the derivative of the bottom, then the integral is the natural log of the bottom. Now, because it wasn't quite exact, we need to times it by 4.5 to make it big enough to turn that 2x into it being a 9x over here. It needs to be 4.5 times bigger. Now we're going to sub in 1 and 4. So we've got 4.5 log of x squared plus 1 when we've got a 4 is going to be 17 minus 4.5 log of when x is 1, that's going to be a 2. Okay, so 4.5 log 17 minus 4.5 log 2 is 9.63 units squared. Okay, D, we are integrating between 1 and k. Now, this fraction, the derivative of the bottom does not give us something that's a multiple of 4. So we need to think a bit more about this one. We're integrating 4 times 4x minus 1 to the power of minus a half. Okay, now we are doing reverse chain rule. I think this one is a fairly straightforward one, so I'm going to go straight into it. If I increase the power by 1, I get a half. I need to divide by the new power. So we had a 4. We're going to divide by the new power. We also need to divide by the number that's inside because we're doing reverse chain rule, so divide by the derivative of the inside. Now 4 divided by a half divided by 4 is going to be a 2, so this becomes a 2 at the front just here. We're going to put in the limits of 1 to k and set that being equal to 6 from what we had in the question. So now let's sub in those limits. 2 times the square root of 4k minus 1 minus 2 times the square root of 4 times 1 minus 1 is going to be equal to 6. Okay, 4 minus 1 is root 3. We can divide everything through by 2, and we'll get 4k minus 1 minus root 3 is equal to 3. If I go, let's just have a look at the question. We don't need exact values, but let's carry on with this anyway. So we've got 3 plus root 3. So 4k minus 1 will be 3 plus root 3 all squared. Then that minus 1 becomes a plus 1. And k will be equal to a quarter of all of that. Okay, let's put that in now. So we've got, we're going to start with the root 3 plus 3, square it, add 1, divide by 4. So k is equal to 5.85. And also, just one thing to point out, you can use equation solver for this one if you don't want to work through all the algebra, because we weren't looking for an exact value. When you get to this line here, we could pop that into equation solver too. Okay, part E is not quite as complicated as it looks. But what we need to start off with is substituting into this formula that we've been given the information over here. Okay, so the RMS is equal to the square root of the integral between a and b, so that's 0 and 2 pi, 1 over 2 pi minus 0. F of x is sine of 2x, and that will be squared. So I'm just going to deal with the integral part of that. We have 0 to 2 pi, 1 over 2 pi of sine squared 2x dx. We're going to need to use our formula sheet to sort out the sine squared 2x. I'm going to use this one here that's got the sine squared in it. So cos of 2a is equal to 1 minus 2 sine squared of a. Let's write that to one side. Cos 2a is equal to 1 minus 2 sine squared of a. I'll just double check I wrote that down right. Yep. Okay. So then sine squared of a is equal to cos 2a, no, 1 minus cos of 2a, all divided by 2, by rearranging that. So let's go back and put that into our integral. First of all, I'm going to bring out the 1 over 2 pi because it's just a constant. We can take constants out and multiply them on the outside of the integral. Sine squared of 2x. So if for the a I'm putting in a 2x here, then 2 times 2x will go into there. So this becomes a half minus a half cos of 4x dx. So it's 1 over 2 pi. A half integrated becomes x over 2. If we integrate cos, we get sine. And then we need to divide by the 4 that's in there. So this will be minus 1/8 of sine 4x between 2 pi and 0. Okay, so it's 1 over 2 pi times by 2 pi over 2, so that's just pi, minus 1/8 of sine of, let me just work this one out. So we've got, right, 2 pi, we're going to times it by 4, and then do sine of that. So that's a 0. Minus 0, take away, well, sine of 0 is also 0. So this is, all we're left with from these bits is 1 over 2 pi times pi, so that's a half. So the RMS was equal to the square root of that. So square root of a half, or 0.707. Okay, question 3. We can't integrate this first one as it is, so let's expand that bracket. So we've got a double bracket, we've got x squared minus, the middle term will be x times 1 over x, so that would just be a 1, but that happens twice. We have 2 of them for the middle terms. Then the final one is 1 over x squared. It's a negative, but times by a negative becomes a positive. So 1 over x, negative 1 over x times negative 1 over x is 1 over x squared. I'm going to rewrite that as x to the minus 2 to make the integration a bit easier. So increase the power by 1, divide by new power. Increase the power by 1 here, we get a minus 1. Dividing by the new power, dividing by minus 1, turns this into a minus, and plus c. Okay, a tree is growing. We've got a rate of growth here. When it was planted, it was 30. What will the tree's height be after 8 years? So whenever you've got a rate, start by writing that rate down in a derivative form. So that'll be 40 t to the minus a third. So then to work out h, we integrate that. If we increase t to the power of 1, minus a third plus 1 is 2/3. And 40 divided by that new power of 2/3 is 60 plus c. Now, when t is 0, we have a height of 30. This bit obviously multiplies away to be 0, so c is 30. What will the tree's height be at 8 years? So when t is 8, h is equal to 60, t times 8 to the 2/3 plus 30. Okay, 8 to the power of 2/3 is 4 times 60 plus 30 is 270 centimetres. Okay, area under a curve. We are integrating between 0 and 6, and our function is 2e to the 0.3x. Now, if we were to integrate e, the e function itself doesn't change, but we divide through by the derivative of the power. So we need 2 divided by 0.3, which is 20/3 is an easier way to write that. We're going to sub in 6 and 0. So we have 20/3 e to the 0.3 times 6 minus 20/3 e to the 0.3 times 0. Let's go e to the 0.3 times 6 e to the 0.3 times 0. That's not right. Let me just go back and put the bracket in that I forgot to do on the 20 divided by the 3. There we go. This is equal to 33.66. Okay, now k splits the area in half. So if we divide that by 2, we need the area to be equal to 16.8. So putting 20/3, and actually I'm going to bring the 20/3 outside the bracket because we can do that with constants. If we go between 0 and k, we need to set that equal to 16.8. So putting in the k will give me 0.3k. Putting in the 0 is e to the 0. That's just 1. Set that equal to 16.83. Okay, so 16.83 divided by 20/3. Add on 1. Do natural log of that answer to do away with the e. Divide it by 0.3. And k equals 4.2. And just do a little check that kind of makes sense with where we think k should be compared to the scale of 0 to 6. You can again use equation solver on this one just here if you don't want to do the manual steps on the calculator. Part D, we have a type of differential equation usually referred to as radioactive decay, where something reduces proportionally over time. So we're told that the rate at which it eliminates itself from the bloodstream is proportional to the amount that we have. So we first of all write that bit down. So the amount that we have is proportional to means we write equals k times the rate that we have is proportional to the amount that is there. Now, separating variables with this one, we bring the n over to the left, so it's 1 over n. Leave the k where it is. We've got dt, integrate both sides. So this is natural log of n is equal to kt plus c, or n is equal to e to the kt plus c. which is the same as e to the timesing by e to the c, which is itself a constant, so we rewrite that as a constant at the front. You can memorize how to get from this to this without doing those steps in between, and I recommend that you do to save a bit of time in the exam. Okay, now let's get some values to work out the missing constants. So after 2 hours, half of the quantity would be gone. So we start with 2 milligrams of nicotine present. Okay, so at the start, let's focus on that one. So when t equals 0, we have 2 milligrams present, so our n amount is 2. Okay, so e to the 0 will just be 1, so therefore a is equal to 2. The second piece of information is that after 2 hours, we will have half of it left. So since we started with 2 milligrams, we'll end up with 1 milligram after 2 hours. So e to the 2k would be equal to 0.5. So k will be equal to half of natural log of 0.5, which I have as a decimal up here if we need it. Okay, now we want to know how long does it take to get to a value of 5% of this amount. Okay, so 2 times 0.05 is 0.1. So for n to be equal to 0.1, we would have this function here. So a e to the kt, where a is 2, e to the k, which is half natural log 0.5 times t, is going to be equal to 0.1. What I've done is put that into equation solver. So you can see I've typed that into equation solver up here and solved it to get that t is 8.6. 8.64, and we're measuring in hours. Okay, last one. We're given the second derivative here. We've got some information about the stationary point, so we need to integrate this to get back to the first derivative and use that to find the stationary point information. Okay, so if we integrate, we are integrating the a squared x minus a to the minus 3. That's so that we can get dy by dx, stepping backwards from the second derivative. Okay, so if I increase that power by 1, we get minus 2. I'm doing reverse chain rule. And then we divide by the new power. Dividing by minus 2 gives me minus a squared over 2 plus c. We would also check we need to divide by the derivative of the inside, but in this case that's just a 1. We're told we have a stationary point when x equals 2a. So we can use that to work out the c that we've got here. So when x is 2a, we know that that derivative, the dy by dx, will be equal to 0 because it's a stationary point. So we have minus a squared over 2. That I'm going to actually bring that bracket of the x minus a to the power of minus 2 onto the bottom of our fraction. So x is 2a minus a plus c. That's going to be equal to 0. So we have minus a squared. 2a minus a is just a, so this is 2a squared plus c. The a squareds cancel, so c is equal to a half. So we've got that dy by dx is equal to minus a squared over 2 x minus a to the minus 2 plus a half. Now we need to integrate that to find y. Okay, x minus a, if we increase the power by 1, we have a minus 1. We will divide by that new power, so we've got a over 2. Half integrated becomes x over 2, and then add another constant. This time I'm going to call it k so I don't get confused with the other c. Let's just rewrite this this bit just here. I'm going to rewrite that as a fraction so that I can put the x minus a on the bottom. So we have a over 2 x minus a, like this. Just makes it a little easier when doing the solving. I just spotted I missed a squared on the a just there from what we had up here for what the derivative was equal to, so I'll just fix that up. Okay, now we are told that we've got this point on the curve here. When x is 2a, y is 2a, so we can use that to find our next missing constant just here. So when x is 2a, y is 2a, so we're going to put 2a in for both x and y. Okay, so we can cancel out the 2 there. We have 2a minus a is just a, so we end up with a squared over 2a. That a cancels with that one, plus an a plus k. So we have a half a plus an a, so that's 3a over 2 plus k is equal to 2a. If we do 2 minus 3 over 2, that's a half, so k is equal to a over 2. It's tempting to feel like you're done. Let's go back to the question and just make sure, what do we need to actually finish with? We want to find the equation of y and the value of y when x is 4a. So finally, when x is 4a, y will be equal to, and I'm using this line just here, but I'm going to sub in the value of k that we've just worked out here. So a squared over 2, 4a minus a, because x is 4a, 4a over 2 plus a over 2. Let's work that through. So we have a squared over 4a minus a is 3a, times it by 2 is 6a. We have 2a here, and we've got half a here. Okay, that squared cancels with that a. So now we have a sixth plus 2 plus a half is equal to 8/3 of a, or 8a over 3. And that's us done.